Good morning, CP Pre-Calc. Now what I'm going to do today is just go over step by step the review problems that you had for an assignment yesterday, just to prepare you for your quiz that you can take either Wednesday or Thursday, depending on when you have time. So the first thing we're going to look at, guys, is we're going to just go over a couple of problems. Now, one had two parts. A is sine of theta was equivalent to 1/2, 1a, and B was sine of theta was equivalent to negative 1/2. What we need to recall here, guys, before we do anything else, is what is sine, cosine, tangent? What is everything equivalent to? Let's remember, sine theta is y, cosine theta is x, tangent of theta is y over x. Cosecant of theta is 1 over y. Secant of theta is 1 over x. And cotangent of theta is x over y. All right, guys? So when we take a look at this, we're going to be utilizing our unit circle. And every problem on the quiz, you will be able to utilize your unit circle. And when they say sine of theta is equivalent to 1/2, we're looking for when the y value is equivalent to 1/2. So when I go to my unit circle, I'm going to go around. Remember, we solve everything for one revolution, meaning I want all my answers between 0 and 2 pi, where 0 is inclusive and 2 pi is non-inclusive. So if I'm finding sine of 1/2, theta is 1/2, I look, when is y 1/2? I do one revolution. I start at 0. Y is 1/2. The first value is pi over 6. So that's one of my solutions. And the next value, I go around. When is y 1/2? Y is going to be 1/2 at 5 pi over 6. So right there, I have my two solutions. Now for the next one, they're saying when sine of theta is negative 1/2. Well, if I'm looking for when sine of theta is equivalent to negative 1/2, I'm looking for when y is negative 1/2. So that obviously will be in quadrants 3 and 4, our y value is negative. So if I look here, y is negative at 7 pi over 6, it's negative 1/2. If I go around, it's also negative 1/2 at 11 pi over 6. So again, those would be my two answers. Now we have to recall, guys, and it's very important that we recall this, that if you take a look at this, when we can also recall that we have all students take calc. This helps me identify when my trig functions are positive or negative. So sine is always going to be positive in the first and second quadrants. Sine will be negative in the third and fourth. Now let's take a look with cosine now. So we have our next one. 2a, I have cosine of theta is 1/2. Now when we're looking at cosine, we're looking for when our x value is 1/2. So when cosine is positive, cosine will be positive in quadrant 1 because everything is, and in quadrant 4. So now I'm saying, when is x 1/2 in quadrant 1 and 4? It's 1/2 at pi over 3, and it's 1/2 at 5 pi over 3. Now for my next one, I have secant. Now what is secant? Secant, remember, is the reciprocal of cosine. So I advise when you're given cosecant or secant to rewrite it as the reciprocal. And if I think about that, the reciprocal of secant is cosine. The reciprocal of 2 is 1/2. So now I rewrote it in terms of cosine, and now I can just say, wait a minute, I'm looking for when my x value is equivalent to 1/2. Well, I just found it. It's 1/2 again at pi over 3 and 5 pi over 3. All right, guys, that's their answer to 2. Okay, let's take a look at 3. Now, 3 is slightly different because we're talking about tangent. So I have tangent theta is equivalent to 1, and I have cotangent of theta is equivalent to negative root 3. Now, tangent, guys, tangent is y over x, and that's what's important for us to know. Y over x. Now, in order for y over x to simplify to 1, y and x have to be the same value. Now, if tangent is a positive 1, I know when I look at this, all students take calc, tangent will be positive in quadrant 1 and in quadrant 3. Now, in order for it to be equivalent to 1, x and y must be the same exact thing. So if I look at my unit circle, I'm looking for when the x and y values are exactly the same. And right here at pi over 4, I have root 2 over 2 and root 2 over 2. So I know that one of the solutions is pi over 4. Now, if I look again, I have to look in quadrant 3. When are x and y the same exact thing? Right here at 5 pi over 4. I have negative root 2 over 2, negative root 2 over 2. So those would be my two solutions to when tangent was equivalent to 1. Now, cotangent. If we take a look at cotangent, cotangent will be positive and negative at the same quadrants that tangent is because they're reciprocal functions. So that means cotangent will be a negative value in quadrant 2 and quadrant 4. Now, I need to somehow have a negative root 3. Now, if I look at this, I don't see a root 3 anywhere. But I know that cotangent is x over y. And you also need to know, we'll make a note of it, that I know I see a root 3. But when I see a root 3, I see it over 2. Make a note that root 3 over 2 over 1/2 is equivalent to negative root 3. The reason why is because if I put root 3 over 2 over 1/2, I can multiply the numerator and denominator by 2, and it would simplify to just a root 3. So now I'm looking for a root 3 over 2 and a 1/2 in quadrants, in this case, 2 and 3. That negative value can go with the numerator or the denominator. So if I want to look for when, again, it's cotangent x has to correspond with that root 3 over 2. I go here, I see a root 3 over 2 over x, negative root 3 over 2 over 1/2 is at 5 pi over 6. Now go over here. I know the other one has to be in quadrant 4. I have a positive root 3 over 2 over a negative 1/2. That would simplify to negative root 3, so that would be 11 pi over 6. All right, guys? Those are some of the basic trig functions that you'll be assessed on. Now let's take a look at this example. Cosine theta plus sine theta, tan theta equals 2. Now, your first thing you should notice is you should say to yourself, I have too many different trig functions. How can I rewrite them so that I minimize the number of trig functions I have? Well, the first thing that comes to mind is that I can rewrite tan theta. I can rewrite that as sine theta over cosine theta. And what you're going to see then is that we can simplify this to sine squared theta over cosine theta. Now, if I have two fractions, two terms that I want to bring together, I can get a common denominator. This cosine is currently over 1. In order to make this cosine have a common denominator right here with that cosine theta, what I need to do is multiply the numerator and denominator by cosine. So cosine theta times cosine theta would be cosine squared theta. 1 times cosine theta would be cosine theta. Now, if we simplify this, you're going to get cosine squared theta plus sine squared theta all over cosine equals 2. But we should recognize right now that cosine squared theta plus sine squared theta is a trig identity. And if we have that, we can simplify by plugging in 1. All right? So now I have 1 over cosine theta is equivalent to 2. Now I can take the reciprocal of both sides and just do cosine theta is equivalent to 1/2. I can easily solve this problem now. If cosine theta is equivalent to 1/2, I'm looking at my unit circle saying, when is my x value 1/2? And I look here, when is my x value 1/2? It's 1/2 at pi over 3, and it's 1/2 at 5 pi over 3. So those are the two solutions to my problem. All right, guys? All right, let's take a look at another number. Let's take a look at number 5. Okay, number 5, we have 2 sine theta plus cosecant theta equals 0. All right, guys? So now again, I have two different trig functions. I'm not really fond of that. But if I look at my trig identities, I would notice that cosecant theta is the same as 1 over sine. And what I can do is use this similar concept that I just used and say, well, if this is sine theta, I have 1 over sine theta, right? I can get a common denominator by multiplying the numerator and denominator here by sine. If I do that, if I multiply my numerator and denominator by sine, I get 2 sine squared theta over sine theta. Now if I take a look at this, I can simplify it to 2 sine squared theta plus 1 over sine theta equals 0. Now what happens here is, in order for a fraction, anytime you have a rational expression, we can recall the only time that that rational expression could be equivalent to 0 would be if the numerator equals 0. So all you have to do now is take that numerator and set it equivalent to 0. Some of you might have just multiplied both sides by sine. You would have gotten the same thing. Now, if I take a look at this, I would subtract 1 and divide by 2. But the problem comes here. If I take the square root, I have sine theta is equivalent to the positive and negative square root of negative 1/2. We are not working with imaginary solutions when we talk about trig. So is this possible? No. So in this case, we have no solution. All right? We're not going to be taking the square root of a negative value in when we solve trig equations. All right, guys? All right, let's take a look at 6. If I look at number 6, I have tan squared theta is equivalent to secant theta minus 1. And again, guys, we need to try to write this in terms of one trig function. Make our lives easier. So if I want to do that, I want to substitute something in for my tan squared. And if I think about it here, I look at that tan squared. Now, the reason I picked tan squared is because tan squared and secant squared are related through a Pythagorean identity. And right here, I know tan squared is equivalent to secant squared minus 1. So I can rewrite this as secant squared theta minus 1 equals secant theta minus 1. And right now, I have an equation in terms of secant. So if I solve this, I can subtract secant and add 1. And add 1. When I add the 1 on both sides, the 1's just cancel. Here the secants cancel. And if you look, I get secant squared theta minus secant theta is equivalent to 0. Now I have an equation that I can factor because secant squared and secant have a common secant factor. So I can say secant theta times the quantity secant theta minus 1 is equivalent to 0. So now you have two things that we're multiplying together, we're finding the product of, and the product is equivalent to 0. So you can set both of them equal to 0 and solve. Now remember, secant is equivalent to the reciprocal of cosine. So if we want to think about this, this is the same as saying 1 over cosine theta is equivalent to 0. Is that possible? Can you divide 1 by a value and output 0? The answer is no. This is not possible. 1 divided by a value cannot equal 0. So the only solution I have to worry about now is secant theta minus 1 equals 0. Well, that's the same as saying secant theta equals 1. If I take the reciprocal of both sides, the reciprocal of secant theta would be cosine theta. The reciprocal of 1 is 1. So now they're asking me, when is cosine 1? Well, cosine is 1 when my x value is 1. So let's take a look. When is my x value 1? I look at my unit circle. My x value is 1 right here at 0, and that's it. Because we're looking at 1 revolution, and 0 is the only time between 0 and 2 pi, inclusive of 0, where cosine is 1. All right, guys, one more problem we're going to go over, and it's 7. Now, in 7, this is an example where to solve it, you needed to square both sides. So let's take a look at that. That means I needed to do sine theta plus 1 squared is equivalent to cosine theta squared. Now remember, when you square a binomial, you need to multiply it by itself. So you need to do the quantity of sine theta plus 1 times the quantity of sine theta plus 1. And that has to equal cosine squared theta. Now, if I distribute this, I get sine squared theta plus 2 sine theta plus 1 equals cosine squared theta. I still have my equation in terms of two variables. I'm sorry, in terms of two trig functions. Now, the whole point of me squaring that was the only way I can look at sine and cosine and convert one to the other is if I use a Pythagorean identity. And the only way I can use a Pythagorean identity is if I have a sine squared or a cosine squared. So if I look here, I see cosine squared is equivalent to 1 minus sine squared, and sine squared is equivalent to 1 minus cosine squared. I am substituting in for my cosine squared because there's only one term with cosine. Here I have two terms with sine, so it would be more difficult. So that means I'm plugging in 1 minus sine squared in for cosine squared. So I have sine squared theta plus 2 sine theta plus 1 equals 1 minus sine squared theta. Now I solve. I bring everything to the left. And what you're going to notice here, the ones all just cancel out. So if I take a look at this, my ones just cancel out. All right, so those ones cancel, and I'm left with 2 sine squared theta plus 2 sine theta is equivalent to 0. Now let's solve it. I can factor out that common GCF. That GCF is 2 sine theta. I factor out that 2 sine theta, and I'm left with sine theta plus 1 equals 0. Now, once I have that, I set both terms that I'm multiplying, the monomial and that binomial that are multiplied together, equal to 0. And I say, well, here sine theta would equal 0 if I divide by 2. Here sine theta would equal 1. Now, I'm going to look at that unit circle. Sine is y, and I'm looking, when is y equivalent to 0? When is y equivalent to 1? Let's start here. If I look, remember, 1 revolution, we start at 0. We do 1 revolution around that unit circle. So if I look here, when is y 0? At 0. I go around, y is 1 at pi over 2. Y is 1 or 0. It's 0 again at pi. Down here it's -1, not positive, so we don't use that. Now I have 3 answers. However, because we squared both sides, whenever you square both sides, you must check for extraneous solutions, meaning a solution that will not work in the original problem. So we need to check. Key thing, check. Check, 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 check. So all 3 of these solutions. So I need to see, can theta be 0, can theta be pi over 2, and can theta be pi? But you must go back, must go back to that original prior to squaring both sides. So let's try it out. I have sine of 0 plus 1 equals cosine of 0. Let's plug that in. Remember, sine is y, cosine is x. So if I look here, sine of 0, here's 0. My sine is y. Y is 0 plus 1 equals cosine is x, which is 1. 0 plus 1 equals 1. That checks. Perfect. Now let's do it again. Sine of pi over 2 plus 1 equals cosine of pi over 2. Let's check. Sine is y. Y is 1. 1 plus 1. Cosine of pi over 2 is 0. 1 plus 1 equals 0. Well, that's not going to check. All right, did that check? No, that did not check. Ah. Hold up, guys. This should have been negative. Okay, guys, here's number 7, the last one from your review. So in number 7, we have sine of theta plus 1 equals cosine of theta. Now, guys, when you take a look at this, when we look at this problem, we have a sine theta and a cosine theta. So we want to think of a way to write them in terms of one or the other. Now, the problem with this here is we can't substitute in cosine in for sine or sine in for cosine. The only way we can possibly do that is if we take a look at this and we know that if I had a sine squared or a cosine squared, I would be able to substitute in for the other. So this is a problem where we square both sides. So if I square both sides, I get sine theta plus 1 squared equals cosine theta squared. Now, remember, this is a binomial. When you square a binomial, you multiply it by itself. All right, so if I distribute this, I get sine squared theta plus 2 sine theta plus 1 equals cosine squared theta. Now I have a cosine squared and a sine squared. But since I have a sine squared and a sine term, I am going to substitute in for my cosine squared term. So I'm going to take a look here, and I'm going to say, well, cosine squared is equivalent to 1 minus sine squared. So let's input that in. So when I input that in, now what I can do is move everything to the left. So I can add that sine squared theta. I can subtract 1. Now, if you notice here, the 1's just cancel out. Now, if you look at this here, we get 2 sine squared theta plus 2 sine theta equals 0. Now I have two terms that have a GCF of 2 sine theta. So I can factor out that 2 sine theta, and I get sine theta plus 1 equals 0. So now I can use my zero product property. I can set both of them equivalent to 0 and solve. So here I get sine theta is equivalent to 0. Here I get sine theta is equivalent to negative 1. Now remember, when we look at our unit circle, sine represents y. So if I'm looking for when sine represents y, I'm looking for when my y value is 0 and my y value is negative 1. My y value is 0 would be at 0 and pi. My y value is negative 1 at 3 pi over 2. But because we squared both sides, when you square both sides, you must check your solutions. Because when you square both sides, you can get an extraneous solution as a solution, meaning a solution that does not work in your original equation. So when you check it, you need to go back to the original equations and substitute the values you obtained for theta in to see if they work or do not work. So if I plug in 0, so I want to try it, does theta equal 0? I get sine of 0 plus 1 equals cosine of 0. Again, look at that unit circle. Sine is your y, cosine is your x. At 0, sine is 0. So I put 0 in, plus 1 equals cosine of 0, which is 1. That checks. 1 equals 1. That's a solution. Now let's try our next one. Our next solution was pi. So you're doing sine of pi plus 1 equals cosine of pi. Well, let's take a look. At pi, y is 0. I have 0 plus 1 equals the cosine of pi, which is negative 1. 1 equals negative 1. That does not work. This is not a solution. So pi cannot be a solution. That is an extraneous solution. Now your last one's 3 pi over 2. If theta is 3 pi over 2, I get sine of 3 pi over 2 plus 1 equals cosine of 3 pi over 2. Well, let's check it out. Sine of 3 pi over 2 is negative 1 plus 1 equals cosine of 3 pi over 2 is 0. Negative 1 plus 1 is 0. That checks. So my two solutions for theta would be 0 and 3 pi over 2. Now, guys, these are the examples to your review. I also am going to download a copy of the answer key. In addition, I put the answer key to several of your homeworks up. So if you look through all the assignments, you should have almost all the answer keys. If you have any questions prior to taking your quiz tomorrow or Thursday, you get to choose which day you take it. Please come to my office hours and ask me questions. All right, guys? I hope you have a great day, and I hope to see you at office hours. Bye.